Good morning, students. Today, shall be looking at redox reactions. Redox reaction is one of the very important reactions in chemistry that we must understand. And at the end of this topic, should be able to give extensive definition of redox reactions, and I should be able to give definition of the following terms: oxidation, reduction, oxidizing agent, and reducing agents. Oxidation has been defined in many different ways in terms of oxygen, hydrogen, oxygen number, electronegativity, and in terms of electrons. So we should be able to familiarize ourselves with how to define this oxidation and reduction in terms of all these parameters. We should be able to identify oxidation, reduction, oxidizing agent, and reducing agent in a particular reaction. A reaction will be given to us, and you'll be asked to identify oxidation, the species that is undergoing reduction, oxidizing agent, and reducing agent. You should be able to understand oxidation number and do simple calculations on oxidation numbers. Thank you as you continue the explanation of the rest of the topic. So, introduction. So we want to introduce the topic now, redox reaction. The redox reaction is an acronym. Redox. The right there means reduction, while the hot there means oxidation. So, redox reaction means oxidation reduction reaction. They are very important reactions in chemistry. Oxidation reduction reactions involve two opposing yet complementary processes. There are two processes that must occur along each other. One cannot occur without the other. So they are complementary reactions. Every oxidation must be accompanied by reduction and vice versa. So let us now look at the definition of oxidation and reduction. Oxidation and reduction have been defined in many different ways, and we are going to look at them now. In terms of oxygen, oxygen is the addition of oxygen to a substance. When oxygen is added to a substance, that particular substance is undergoing oxidation. While reduction is the removal of oxygen from a substance. If oxygen is being removed from a substance, that particular substance is undergoing reduction. Now, in terms of hydrogen, the definition of oxidation and reduction in terms of hydrogen. Oxidation is the removal of hydrogen from a substance. When hydrogen is being removed from a substance, that particular substance is undergoing oxidation. While reduction is the addition of hydrogen to a substance. So they are opposing reactions. In terms of electronegative elements, electronegativity or electronegative elements are elements that attract electrons to themselves. They are highly non-metals. Okay, and most of them are fall under allergies. Okay, allergens. They are mostly electronegative elements. So we want to define oxidation and reduction in terms of electronegative elements. Oxidation is the addition of electronegative elements, while reduction is the removal of electronegative elements. When electronegative element is being added to a substance, that substance is undergoing oxidation. But if electronegative element is being removed from a substance, that particular substance is undergoing reduction. Let us look at the definition in terms of oxidation number. We are going to see the definition and the meaning of and how to calculate oxidation number in the next slide. So, oxidation number in terms of oxidation in terms of oxidation number is the increase in oxidation number. When oxidation number is increased in the positive direction from reactant to product, when it is increased in the product in the positive direction, maybe from 1 to 2, or from 0 to 5, or to 3, that particular substance that has an oxidation number increase is undergoing oxidation number oxidation. Why it is a decrease in oxidation number? Reduction. Reduction is a decrease in oxidation number. When an oxidation number decreases from reactant to product, that particular substance is undergoing reduction. And lastly, in terms of electron, oxidation is defined as a loss of electrons, while reduction is defined as a gain of electrons. This is why question. Why still? Define oxidation in terms of electron transfer. We are being asked to define oxidation and reduction in terms of electron transfer. Is referring to the last definition, that oxidation is defined as a loss of electron. Whenever electron is lost, that particular substance is undergoing oxidation. Why reduction is the gain of electron. So I want to establish that. We have to see how we can identify. We'll look at definition of oxidizing agents and reducing agents. Having known how to define oxidation and reduction, we now look at the definition of oxidizing agents and reducing agents. An oxidizing agent is a substance which accepts electrons, while a reducing agent is a substance which donates electrons. That is a simple definition of oxidizing agent and reducing agent. Let us now see how they are related to oxidation and reduction. Note that any substance that undergoes oxidation is a reducing agent. Again, any substance that undergoes oxidation is a reducing agent. Also, any substance that undergoes reduction is an oxidizing agent. Once we can identify oxidation and reduction, it is very easy for you to identify reducing agent and oxidizing agent. Let us see reactions that will explain that. So that we'll be able to identify oxidation, reduction, oxidizing agent, and reducing agent in a particular reaction. Look at this example. Consider the following reactions, which will undergo oxidation, reduction, oxidizing agent, and reducing agent. So, look at this reaction. Zinc oxide is reacting with carbon to give carbon oxide and zinc metal. If you look at this reaction very well, we want to identify the species that is undergoing oxidation, reduction, oxidizing agent, and reducing agent. How can you go about it? Now, this can only be gotten from the reactants alone. You can only get this from the reactants. The product will only help you to identify them. You cannot get all these species from the product. They can only be gotten from the reactants only. Now, if you look at the first element there, carbon. Carbon is standing alone at the reactant side. When it gets to the product, carbon has combined with oxygen. Oxygen has been added to carbon. And we said oxidation is the addition of oxygen to a substance. That means carbon is undergoing oxidation. Very easy. We look at zinc oxide at the reactant side. Zinc oxide at the reactant side is having oxygen. When it gets to the product, the oxygen has been removed. And we said reduction is the removal of oxygen from a substance. That shows that zinc oxide is undergoing reduction. And oxidizing agent, any substance that undergoes reduction automatically will undergo will be oxidizing agent. And any substance that undergoes oxidation will be reducing. That means zinc oxide is oxidizing agent, while carbon is a reducing agent. Let us look at the second example. Hydrogen sulfide gas plus chlorine gas to produce hydrogen chloride gas plus sulfur. Now, if you look at this reaction, Hydrogen sulfide at the reactant site, the sulfur there is has combined with hydrogen. That is why we are having hydrogen sulfide. At the product side, the hydrogen attached to sulfur in the hydrogen sulfide has been removed, and sulfur is being deposited. And we define oxidation as the removal of hydrogen from a substance, because the hydrogen sulfide is removing oxygen at the product side. So we said hydrogen sulfide is undergoing oxidation. We look at the chlorine at the reactant side. It has no hydrogen at the reactant side. When you get to the product, hydrogen has been added to chlorine to make it hydrogen chloride. Because we have added hydrogen to chlorine at the product side to give us hydrogen chloride, that means chlorine is undergoing reduction. And the oxidizing agent is chlorine, reducing agent is hydrogen sulfide. Very easy. Now, let us look at the third equation or example. We have iron 2 chloride reacting with chlorine gas to give iron 3 chloride. Now, and we want to identify oxidation, reduction, oxidizing agent, and reducing agent. If you look at the iron at the reactant side, it's iron 2. At the product side, it has turned to iron 3. And we said oxidation is the increase in oxidation number, because the oxidation number of iron has increased from iron 2 to iron 3. That means iron 2 chloride is undergoing oxidation. Why chlorine? If you look at chlorine, element that is standing alone, uncombined, in the uncombined state, that is not combining with any other element, has oxidation number of 0. So chlorine there has oxidation number of 0 at the reactant side, and the product side is having oxidation number of -1 because it's forming a compound. So because the oxidation number of chlorine is decreasing from 0 to -1, so chlorine is undergoing reduction. The oxidizing agent there is chlorine, while the reducing agent there is iron 2 chloride. Now, we then look at oxidation number and how to calculate oxidation number in of an element in a compound. The oxidation number of an element in any particular molecule or ion is defined as the electrical charge it appears to have, as determined by a set of arbitrary rules. That is the definition. Let's see how to calculate this as given in an example below. Calculate the oxidation number of manganese in potassium tetrahydromanganese 7. Yes, this is a typical Y question. Y will ask you to calculate the oxidation number of a particular element in a compound. In this case, it's manganese. Now, this is a compound that has no charge. Because it has no charge, the sum of oxidation number of all the compounds is 0. So, we now look for the valencies of other elements aside from manganese. So, the potassium there has a valency of 1 because it's in group 1. So, the 1 plus manganese, we are looking for the oxidation number of manganese, is serving as X. Plus the 4 is attaching to oxygen. So that 4 times the oxygen number, the valency of oxygen, which is -2. So 4 times -2, everything equals 0. So then 1 plus X, 4 times -2 is -8, equals 0. So X, 1 minus 8 is -7, to give us 0. When 7 cause the positive sign, -7 cause the positive sign, it turns to +7. So X is equal to +7. And the oxidation number of manganese in that compound is 7. That was the reason why we said the name of the compound is potassium tetrahydromanganese 7. Thank you for listening.